Before we applied this overhead using one simple allocation scheme, and that was the machine hours, and we spread it all out based on the machine hours used by each customer. Remember that one customer is complaining their costs are too high, and so we've looked at our process and we've said, you know, we could really do a better job of splitting this overhead up. And we've identified three different cost drivers within our manufacturing process, one being design, two being production, and the third being engineering. And we've decided we could split the cost based on CAD design hours for design, engineering hours for production, and machine hours for engineering. Um, and I realize there's probably an error in how I typed this up. These should probably be flip-flop, but I'm just going to leave them because I've already done the first part of the problem. So if you're wondering why our engineering hours for production, yeah, it probably should be switched. But irregardless, the methodology still works the same way. And so we were able to allocate or pool our costs for design, production, and engineering. We were able to come up with the costs. We somehow allocated this 306,800 based on these three amounts. So now we're going to have to come up with a different overhead allocation for each customer using these three different cost allocation methods. So I'm going to set it up something like this. I'm going to calculate the hours for CAD, for engineering, and for the machine hours for production. And I would say we had 39,000 that went to design, 29,600 to engineering, and 240,000 that went to, this should be production, but whatever. So we now know that the total, so this is my cost. The cost pools equal this much, and we got the allocation base, design hours. Total design hours, I'm going to take the amounts from each of the three customers, so the 110 plus the 200 plus the 80, we have 390 hours in design hours for CAD. I probably can't even put that label here, right? Well, I can move it down here because it's going to be then engineering hours for the next one. And again, I'm going to take the 70 plus 60 plus 240, gives me 370, and this last one is machine hours. And I'm going to take this 120 plus the 2800 plus the 1080, 4,000. So the amount I'm going to spread out per hour is this amount, $100 for the CAD, $80 for engineering, oops, and it's going to be 60 bucks an hour for the machine hours. So that's the rate at which I'm going to apply to each of these three activities or cost drivers, I guess. And I'm going to lay this out like this. I've got CAD, engineering, and machining. And I've got three different customers. I've got United, Holden, and Leland. And you could, well, I could lay it out a little bit more detailed so you could see it, but I'm just going to tell you how to do it. You're going to take the rate we just calculated for the CAD area. We're going to multiply it by the quantity used by United, which is 110. So they would get this much allocated for the CAD function that they've consumed, 11,000. Holden would get this same $100 times the 200 hours that they've used. And Leland gets the same $100 but times the 8 hours they've consumed. Engineering, the 80 hours for United, or the $80 an hour, excuse me, times the 70 hours that United consumed. For Holden, they took 60 hours times that $80, and for Leland, the $80 times 240. Lastly, we have for the $60 per hour allocation, United used 120 hours. Holden at 60 bucks an hour used 2,800, and Leland at $60 an hour consumed 1,080 hours. So here are my total indirect cost allocations. If I then sum each of the three methods, this is my answer right here. I'll just highlight it. Not sure why I'm highlighting it, but I will. So that's the answer to this one. And you can compare that to the first one, and we'll talk about that in the next section of the requirements.